Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
So hello everyone. Welcome to the session. So let us wait a few more minutes so that other people can join and then we can begin. So hi Vivek, how are you? Yeah. So I would request those students who are right now present in our session. So kindly write your name in the chat box so that to mark your presence, and then we can start as soon as possible. Yeah, I would request you all to please write your name in the chat box. And meanwhile, I am presenting my screen as well. And the link to the Google Jamboard slides are already there in the description of this stream. You can refer from that. Uh, so just a minute, let me share the screen then. Yeah, so I hope everyone can see and just give me a confirmation that I am properly audible and visible and my screen is also properly visible to everyone out there. Okay. So anyone can just confirm in the session and then we can very quickly start. We see people are joining. Hello Vivek, how are you? You can write your names in the chat box as well. Okay. So let me give you a very small introduction about myself and about this session as well. So this is the graph and tree session, and we are doing today is the ninth session in fact, and we are basically studying all the important topics and concepts related to graphs and trees, and which are basically important from interview point of view. So we have discussed a lot of our concepts related to graph, and today and in the next two sessions we will be dealing mostly with practice problems. Okay, so yeah, and these problems are very important from interview point of view because they are very frequently asked in popular interviews questions as well. Okay, and from the month of January we will start with our tree series. Okay, and in that tree series I will be discussing the concepts of various types of all the concepts there are there for tree chapter, and we will be discussing all the famous interview questions as well. Okay, so in the month of December it's all graph, and then in the month of January it will be all tree. Okay, so this is about the session. Today is in fact the ninth session, and we have already covered topics like the representation of graph, traversal techniques of graph, BFS, DFS. We have also seen about multi-source BFS, zero one BFS. We also did questions about Dijkstra. We also did question about Bellman-Ford algorithm as well. We learned about topological sorting. We learned about connected component, detection of cycle, various other concepts as well. Okay, so you can find these lectures recorded in the YouTube channel itself. And I would request everyone kindly to please like this session as we are pattern questions will be covered. What do you mean by pattern questions? Like we will be covering the questions for graphs and trees. Okay, graph data structure and tree data structure. Okay, and all the important interview questions. Okay, so this is it. And I would request everyone to kindly like this session first of all in the YouTube and subscribe our channel as well. Okay. Apart from that, right now at Geeks for Geeks YouTube channel, something called interview preparation series is going on, where we are having a lot of guests invited who take live sessions and guide you related to cracking interviews in various companies.
Interview preparation
Okay,
series.
so you can check the link in the description. And in fact, tomorrow, that is 24th of December, we are on 24th of December, we are having a live session with our CEO, Mr. Sandeep Jain, in which you will get a Zoom link, and you can that will be basically an Ask Me Anything session, in which you can ask anything you like to our CEO, Mr. Sandeep Jain. You can check out the link in the description of this video of this stream. Okay, you will find the details about that. Yeah, so let us start then. In fact, are there any questions that you would like to ask, or we can just start with our discussion then? Yeah, so I guess everyone can see the question as well. So, yeah, so the first question that we are going to study is the prerequisite task. Okay, so can you all see the screen, I guess? Hmm. So, let us see what exactly the question statement says. Yeah, so basically, yeah, so how exactly are we going to solve this problem? Let us read the problem statement. This is the, just a minute. Yeah. So this is a question. So let us look into the question first. The question says that we are given n tasks, okay, labeled from 0 to n minus 1. And then some task may have prerequisite. For example, if you want to do the task number 0, you have to complete the task number 1. Okay. So this form of information is presented in the form of 0, comma 1. So what does this mean? This means that in order to complete task number 0, you should complete task number 1 first, then only you can complete task 0. Now, according to the question, you have been given two tasks. Task n, you have been given n tasks, okay, and a list of prerequisite pair p as well. Now you have to find whether it is possible to successfully complete all the tasks or not. Okay, so how am I going to solve this problem? Any ideas, anyone? Yeah. So let's look into an example first of all. So let's say there are four tasks, and let's say there are three prerequisites. So the first prerequisite says that in order to complete task number 0, you have to complete task 1. In order to complete task 1, you have to complete task 2. In order to complete task 2, you have to complete task 3. Okay, so the output is yes. And why so? Let's say to do task 1, you should complete a task 0. Okay, to do task 2, you should complete task 1. And to do task 3, you should complete task 2. So it is possible. Okay, So basically, let's say you are doing task number 0 at the first, then you can easily do 1. Okay, because you have completed 0. And since you have completed 0, you can very easily do task number 2 as well. And since you have completed 2, you can very easily do task 3 as well. So it is complete. So we will output yes, because yes, it is possible to complete all the n tasks according to the given set of prerequisites. Now the question is, yeah, now the question is that let's say there are two prerequisites. The first is 1 comma 0 and then there is 0 comma 1. So it means that in order to complete task 1, you should complete task 0, and in order to complete task 0, you should complete task 1. So basically these two are contradicting each other. So in that case, what we get here, we will not be able to complete both of the tasks. So in that case, we will output 0. Okay, so did you all understand this? Hello Tejas, are you there in the stream? Hello Vivek. So, am I properly audible and everything is going well, right? So, yeah, hello Sumit, how are you? Are very regular students who are coming to this series from the very first time, very first session, in fact, and he's been attending all the sessions, right? And hello Utkash, how are you? Yeah. So, okay, then in that case, yeah, we are doing a question. So, once again, please, Joel is asking once again, do you want me to repeat the question once again? I am pasting the link in the chat box. Okay, so in that case, you can refer the question. Okay, give me a minute. Yeah. So, if anyone has any idea how we are going to solve this question, just write it briefly in the chat box. Yeah. Anyone? Hello, Sumit. Can you please write how exactly, any basic idea about what concept it will involve to solve this type of question? Okay, this is actually a very famous interview question as well, and we will see how we will solve them. Okay, so let me share the tab. Okay, okay, so basically, what exactly I was trying to say here is that we have got n tasks and we have got p set of prerequisite. So prerequisite basically means, let's say A and B are given like this. So it means that in order to complete task A, you should complete task B first. Okay, this is a condition, and there are p pairs are given, and you have to follow these p pairs, and you have to say that whether it is possible to complete all of these n tasks given that you are following all of these p pairs. Okay, if you are able to get that, you will just answer yes. So what exactly do we need here? Okay, first of all, this is a graph problem. Okay, so even let's say if you're just reading away the question for the very first time, the first and the most important thing that you have to identify here is that you have to basically model that yes, this is a graph problem. And in graphs, what happened? We got vertices, we got edges. So can you tell me what will be vertices and what will be edges in this question? Don't know the question. I have pasted the link in the chat box. You can refer Sumit. The question is already there in the screen. Okay, so tell me how we are going to do it. Okay, so let's see how exactly we will solve this question. Okay, now the first thing that is coming to our mind is that in the pre-pairs, what we have been given are nothing but dependencies. Okay, it means that completion of one task depend on the other task. So how can we model this idea? How can we model this idea in the form of a graph data structure? Okay, okay, now we know that every two vertices has an edge connected between them. Okay, if I say that this is vertex number one, this is vertex number two, these two nodes have an edge connected to them. An edge basically denotes that there is some kind of connection between the edge number one and two. Okay, it means that one is connected to two and two is also connected to one. Now, when I say that, let's say you have been given a prerequisite AB, and I say in order to complete A, you must complete B. Okay, so what does this mean? Okay, it means that, let's say, this is this is a node denoting the node A. This is a node denoting the node B. Okay, now in order to complete A, you have to complete B. Okay, so basically I can say that you can only go to A uh, hmm, by going through B. Okay, so what does this mean? Just have a look at the question first. The question says that, yeah. So question says that in order to complete A, you must complete B. So basically, you can only go to A once you if you are going to B first. Okay. So let's say in order to complete B, you must complete course C. So let's say you just completed course C. Now you have the freedom to go to course number B. Now you can just completed course number B. Now you can go to course number C. So this entire thing we can represent it by a directed graph. Directed graph. Okay. So, what we are going to do first of all, whenever we are getting an input of our prerequisite, we will convert them into a directed graph. Okay. Now we have converted them into directed graph. Now what else? Just conversion of them into directed graph will work. Tasks topo sort. Okay, Vardhan, topo sort. Hmm. Nandan, hello, Veen. So let us see how. Okay. So when will we just saw in the example that in the second case it was failing. Okay, we were not able to conduct our task. Can anyone tell me at in which conditions we will not be able to fulfill our we will not be able to complete all the end tasks? When we will fail to complete end tasks. Okay, so Nandan is saying topo sort. So let us see how. The I was waiting for someone to write the condition. The condition will basically be that it is n. It will be that it is n. Okay. Okay, yeah. So it means that if there is a cycle in the graph, if there is a cycle in the graph, in that case, what will happen? We can very easily say that we will fail to complete our end tasks on time. Okay. So the question involves that we have been given a directed graph and we have to see that whether there is a cycle or not. If we are able to find a cycle, then in that case we will just say yes, we will not be able to complete the tasks. Okay. So this is one aspect. Now the second aspect is someone is saying he write the order as well. Okay, so how we'll do that? Okay, so in order to do that, and someone mentioned in the chat box about topological sorting. So we have already covered the idea of topological sorting previously. So let me just give you an example. So what happens in topo sort is that, let's say you have a node U and another node V, and let's say U is connected to V. So in our topo sort, what happens is U node will come before V in our topo sort. The way we will basically print the topo sort. Okay, so this is how we will be doing. So U should be connected to V. So now in the question, what was asked here is that you have similar type of pattern in the question as well. Okay, so a similar pattern in the question as well. Now this was basically saying that. Hmm. So this was basically saying that you have to. What you have to do here is that let's say if this was a connection, it means that in order to complete task number v, you have to first complete task u. So if someone is asking you, print the order as well in which you will complete the task, so in that case you should print u before v. Okay, so what does this mean? If we are able to find a topological sorting of our given directed graph, then we can very shortly say yes, we will be able to complete the subject, and you can also specify the order in which we should complete. Because in topological sort, what is happening, if u is present, if this condition is present, in that case u will be printed first. Okay, so this was the condition. Yeah. So number of vertices is not equal to topo dot size. In that case, we will return false. Otherwise, we will return true. Yes, Nandan, that is correct. Hello, Naikaj, how are you? So we are solving a question related to topological sorting. So I have already pasted the link in the chat box. You can follow it through. Okay. So let me share the screen then of the problem statement and let us solve it. Okay. So what exactly is our first step? Can anyone tell me what should be our first step? The first step should be to create a directed graph. Okay, so we already have a vector called prerequisite. Now from that vector, what we are doing, we are creating our graph in the form of an adjacency list. Okay, so the first step is creating a graph in the form of an adjacency list. Okay, creating a graph in the form of adjacency list. Okay, so this was the first step. Now what should be the second step? Second step should be to calculating in degrees. Now we have already learned about toposort using BFS. Okay, using BFS, and that is called okay, and that is called Kahn's algorithm. Okay, now the first step in Kahn's algorithm was calculating in degree. Okay, now in the first step we will be doing calculating in degree. Okay, so how to calculate in degree? Everyone, I hope you guys know. We basically have to see that after we have created our directed graph, and yeah, so we create a array called in degree and we initialize it with number of v. Okay, so in this case, basically what is v? Can anyone tell me? V is a number of vertices. Okay, and m is the number of edges. So in this case, v will be. Okay, so this will be v. So in that case, let me just name the number of edges and tasks. So this should be v. Okay, I've changed the parameter. Now, whenever a node is entering into another node, the integrity of that particular node, the node in which it is entering, it becomes 1. Okay, so how many nodes are coming inside that node is equal to the integrity of that node. And why do we calculate integrity? Because let's say a node is getting connected to another node, it means a directed node is leading to that node. So the node in which some another node is coming, it should be placed after that node. Okay, this is the first step. That is why we need to get an in degree. If an in degree is, let's say, 5, it means that 5 nodes are entering into that node. So the thing is that that particular node should be placed after all the initial 5 nodes from where that node is ending. Got it? So that is the concept of in degree. And we are calculating in degree. Now after that, what we do, we declare a Q data structure, because topological sorting involves BFS algorithm. So we have calculated it in degree. Now, after we have calculated the in degree, we will push all those nodes which have an in degree equal to 0 into our queue, inside our queue. Okay, so we will push all those nodes inside of a queue which have an in degree equal to 0. So this part is also done. This is one of the primary steps required to calculate for our topological sorting. Okay, this part is done. Now we will declare a vector called topo. So we declare a vector called topo. In this vector, we will be basically storing our topological sorting. Okay. Now let us look into this loop. So this is the very crucial loop of converting the topological sorting. So this is a type of a BFS. Now, how long this queue will work? This while loop will keep on working as long as our queue is not empty. So when the queue becomes empty, it means that our BFS is over. So what we will do? We will take the node from our queue, the front element of our queue. Everyone knows about queue data structure, I hope. So we take the front node from our queue and we pop that out. We push that into our topological sorting. Why we are doing that? So exactly why we are doing that? We are doing that because in our queue, in the during the very first iteration, only those elements are present in our queue which are having an integrity equal to 0. An integrity equal to 0 means none of the nodes are coming inside that node. Everything is going outside. So if every node is going outside that present node, it means that it should be placed on the very first point only in our topological sorting. So that is the reason we are taking the top element from our queue and pushing it inside our answer vector. Okay, and then what we do? After that, simple BFS. We will try to go across all possible adjacent nodes of our given graph. And then what we will do, for every adjacent node we are visiting, we will decrease the integrity by 1. Decreasing the integrity by 1, it means that since we are visiting a graph, it means that particular execution is done. Let us decrease the integrity by 1. Decreasing the integrity by 1 means we are basically decreasing the number of edges connected to it by 1. It means that that particular edge walk is done. Now we will check whether the integrity becomes 0. If the integrity becomes 0, we will again push it into the queue because now it becomes a part of our topo sort at its right position. So after this entire while loop gets done, what we will do basically, we will return topo. Okay, we will return the topo vector. So now this will basically help us get the topological sorting. But this was not our question. The question was to check whether we can complete the end tasks or not. Okay, so how to do that? Okay, now what the question is asking us basically that we have to try to Yeah, really sorry, there was a small technical glitch. So let us continue then. So according to the question was not asking us to return the topological sorting. The question was basically asking us to return whether it is possible to complete all the end tasks. Okay. Yeah. So basically what we will try to see is that the size of our topological sorting is equal to V or not. Okay. So is equal to V or not. Now why exactly we are doing that? Basically we are checking that there are V nodes in our graph or not, in our topo vector or not. If there are V vectors in our topo vector, then we are returning topo. If not, we will return an empty array. Empty array will denote that yeah, basically we do not have yeah, so basically it is not possible. Okay, so in fact in the question basically it was not asking us to return the order, it was just asking us to return true false. So in that case we will not return this vector, we will just return true or false. A false will denote a -1, okay, or in fact 0. Okay, so this is it was a boolean vector, and boolean vector are always 0 and 1. So let us submit this question and see whether it is correct or not. Yeah. So yeah, so did you all understood this question? So there was a small compilation error. In the error, it is saying that operator IT1 no match for pair. Okay, so IT across prerequisite. Prerequisite is nothing but a it is a vector of pair. Okay, so it should be IT of dot first and dot second. Okay, it should not be one. So this should be IT dot second. Okay, it should be IT dot second, and IT of 0 should be IT dot first. Okay, so let us now submit the problem and see. So hello Naikaj, are you there? Hello Sumit, are you there? Did you all understood the question? So as you can see, all of our test cases have successfully been passed. So therefore, this question is correct. This answer is correct. Okay. So now let us move to the next question. And before that, do you have any doubts regarding the question? So can you please tell me? Any doubts, anyone? Did you all understood the question? Hello Naikaj, hello Sumit, hello Nandan, hello Joel, are you there? Hello Utkarsh, are you there? Hello Tejas, hello Vivek. So is the question clear to everyone? So should I move to the next question? Yeah, I would request everyone to kindly keep the chat box a bit interactive so that it gives me a bit of motivation to study to create a better content for you all. Okay, and this will also keep you interested in your studies as well. Okay, so this is a kind request from my end. Okay, so let us move to the next question then, in case if you all do not have any doubts. So just a minute, let me open the next question. The next question is going to be a bit difficult than the last question we just did. So let's see the question then. Okay, so let me share the screen. Yeah. So this is the question, and as you can see in the question, it is given that there are n cities and m edges connected from some number of flights. Okay, and you are given array of flights where example flights of I indicates two three variables. The flights indicates that from where it is coming to where it is going and the price required to it. Okay, so and we have to find the we have been given three integers. The first is source, the second is destination, and the third integer is k. So we have to return the cheapest flight from the source to the destination with at most k stops. Okay, and in case if there are no such routes, in that case we will just return -1. So how will you do this? Any idea? Okay, so the first and the most important thing related to this problem is that we have to understand that how this problem is related to our graph data structure. Okay, now we see that what do we have? We have nodes. Okay, we have been given three values. The first value represents. So let me share the screen and then we can proceed. Okay, so this is the first value. So this represents. So this is, let's say, this is the value. So let's say this is a node number 0 and this is node number another node. Okay. So this is a place I and this is another place j. And there is an edge connected between these two places, which basically has a weight, which indicating the cost from traveling from city A to city B via flight. So any valid edge between any given node is a valid route for a flight. Valid route of a flight. Okay. Now, this is a valid route, and every valid route contains two things. The first is city number A from where it is originating. The next is city number B. Okay, so it is flight is going from city A to city B. So in that case, what we should have our graph as directed. Okay, so this will be our graph. Done. Now we are going from city A to city B. This is done. And there is a cost associated from going from any of the cities. So the cost associated to go from city A to city B is also given. So in our input, we have three values: the origin city, the destination city, and the cost associated with it. Now we have been given this for all possible flight routes that exist. Now, now the question is basically is that we have to basically find the we are also given two things. The first is the source, then second is the destination, and third is the value k. So what does this k means? K means that a passenger will go from source to destination by going through at most k stops. So let's say a passenger wants to go from node number A to node number B, and there are two stops, node number C, D, and E. Let's say. So basically, A can go from C, C can go from E can go to B, C to go to B directly, C can go to D and then to B. Okay, so as you can see, a passenger can take at most a passenger is allowed to take at most k stops. So how many ways are there? So what we can do, we can go from A to C and then from C to B, then from C to E to B. Okay, so when we are going through C, number of stops is equal to 1. But when we are going through E, the number of stops is equal to 2. Okay, so yeah, so basically this step is also valid and this step is also valid. Okay, from C it is also valid, from E it is also valid. And when it is going through D, then that is also valid because there are two stops, C and D. Okay, the source and destination doesn't come into the stop. Between the source and destination, we should have at max k stops. Okay, now the question is that since there are multiple possible ways, we have to only consider those values which are the cheapest. Okay, so we have to minimize the cost as well. Minimize the cost as well. So how can we solve this problem? Can anyone tell me which graph algorithm will help us to solve this problem? We have 9 people with me right now. So anyone who would like to say which graph algorithm will help us to get a route starting from the source to the destination such that the score between the cost is minimum and at the same time it doesn't exceed the number of stops that we are allowed. So we have to take care of two things here. The first is the number of stops and the second is the cost. Number of stops should be at max k and the number of total cost should be as minimum as possible. Okay, so how can we do that? Anyone, any idea? Yeah, anyone, any idea? We will plot a graph. Yeah, we will plot a graph. Definitely, this is a graph problem. Okay, but I'm asking which algorithm, which graph traversal algorithm, maybe we will use that will help us to model this concept in the form of a answer. Okay. Anyone? Yeah. So let us see how we will solve this question. Okay, so we have learned a very important algorithm called the Dijkstra's algorithm. Okay, so we have to apply the concept of Dijkstra algorithm. So how we will do that? Let us see. So if you just recall from our last session, we learned about Dijkstra's algorithm. Now in that algorithm, what we studied was we had to find the minimum distance from a source node to all the nodes. Okay, so let's say this was our source node and there are various other nodes, let's say A, B, C, D, whatever there was, and it was a directed graph. Okay. So the question was to find the minimum cost from going from source node to each of the remaining nodes. So we had a distance array, right, in which we were storing our answers. So the cost for traveling from node number 0 to node number 0 was basically zero. Okay, node cost. And whatever, let's say, the cost from traveling from node 0 to A will be the edge weight. And in fact, if we are able to find a minimum, we were just updating our distance array. So this was the idea of Dijkstra's algorithm. And as you can recall, we were using priority queue data structure to our Dijkstra's algorithm. Why a priority queue? But this priority queue was also of the type min heap. Why a min heap is that we were inserting the things like we were inserting inside of a priority queue the distance and the node value associated with the distance. Okay, so whatever distance will be minimum will come on top of the priority queue, and we will process that according to the rules of our Dijkstra's algorithm. Okay, so what is happening here is that whenever we are getting a value which is better than the previously encountered value of the distance, we are updating our distance value. Okay, so this was the idea of the Dijkstra's algorithm. You got get it? Now what we will do in this question also things are same. We have to find the cheapest. We have to find the cheapest. Okay, cheapest airfare. So what does cheapest means? Cheapest means that the cost should be minimum. Okay, so cost is equivalent to distance here. Okay, so distance should be minimum. So will Dijkstra's algorithm help me solve this question problem? Okay, hello Shikhar, you are from class 9. That's very good. Welcome Shikhar. Uh, you can check out Geeks for Geeks courses and everything that are relevant for school level children. This is quite an advanced topic for you, but I would like you to please have a look at this topic and try to understand. It may be difficult for you right now, but you can check out other introductory level courses at Geeks for Geeks, which basically contains a vast repository of various things related to computer science. Okay, and it may happen that you find these things interesting. Okay, so yeah. So the question was that will Dijkstra's algorithm be sufficient? So, will Dijkstra algorithm be sufficient to solve this problem? Why we are saying that? Because in the Dijkstra's algorithm, we were using a priority queue, and that priority queue we had to give our distance as the first parameter, and only those nodes which were coming on top of the priority queue had the minimum distance. So what does this mean? Having a minimum distance, it means that that particular node we were assessing first. But in this question, distance should be minimized. But before we are minimizing distance, we should take care of one more thing. That is, we had to make sure that we are going in at most k number of stops. Okay, so what we will do, the first and the most important parameter of a distinction becomes the number of stops. So instead of writing in this fashion, we will write something like this: node the first parameter that we will insert in our priority queue will be the stops, the number of stops we had taken till now. Then we will go to the distance, and then we will go to the node. Okay, we'll put three things in our priority queue. Okay. After that, what we will do, we will check whether the number of nodes are, we will, because in the question it is mentioned that we can take at most k nodes. Okay. That is the reason, if you are able to reach the destination. Now, one more thing. The next thing here is that we will complete our Dijkstra's algorithm according to the rules of our Dijkstra's algorithm. Okay, why so? Because let's say if at any point of time our number of the number of stops are getting, let's say we are basically reaching the number of stops. Let's say there were 3 stops, and we saw that we are able to reach the destination within 3 stops at a price of, let's say, c, at a cost of, let's say, c. So does that mean we will stop our Dijkstra's algorithm at this point? No. Why? Because let's say we are moving at a 3 step, so there may be possibility that another path which can also move in 3 step, or maybe a lesser number of stops, but at a very better cost than c. It may be possible. So it is possible that the stops are same, the number of stops are same, but the cost is decreasing. So what we will do, we will always have our distance array, and we'll try to update our distance array according to the rules of Dijkstra. If we are able to find a path of a lesser value than a path of basically a lesser cost, then we will update it accordingly. Okay, so this was the idea of the question. So let us look into the coding part of it. I'm sharing the link of this question in the chat box so that you can have a reference for yourself. Yeah, so we have 9 people with me right now in the stream, and in fact, it's 10. So I will request everyone to kindly like this session and subscribe the Geeks for Geeks practice channel. So basically, we have been planning a lot of content over the next few months, and this is the graph and tree series. This will continue till the January, and from the month of January, we will also start a DP series as well. Okay, a dynamic programming series. So all these series are focused upon solving concepts and questions which are very frequently asked in your interviews. Okay, so please subscribe to this channel as well. Okay, so let us see how to solve the next part. So let me just increase the size of this. Yeah. So in the question we have been given n is the number of nodes or the number of cities. We are given a vector which contains flight. So this flight basically denotes three things. The first thing it is denoting is the source. The second it is denoting is the destination. The third it is denoting the cost required from going from stop number A to stop number B. Now we have been given three parameters. So the question wants us to go from source to destination by taking at most k stops. Okay. So what we will do? The first and the most important step here is that the to construct a graph. Okay, because we have identified that this question involves the concept of graph. So we will construct a graph. Okay. After we construct a graph in the form of an adjacency list, so this adjacency list will store two things. Okay. It will store the connection between node number A to node number B, so U and V, and also it will store the weight. Weight is in basically denoting the cost. So we take the first three values from our vector because it has got basically k is the number of flight. Let's say flights dot size, small k. Okay, it is the size of this vector. So it contains there are k number of values given denoting the destination route of each flight from city number A to city number B. So we see we will construct our loop. So it means that in order to go from U to V via flight, it will take cost WT. So we are connecting U to V. So how do we connect? Adjacency of U dot pushback V comma weight. So we have constructed our adjacency list. Now it is time to construct our distance array. So this is our distance array. This is just according to the rules of Dijkstra's algorithm. We were constructing a distance array. Now we were putting the value 1e9. 1e9 is basically a very large value. So how? Because we are trying to minimize our distance at every step. So we have to make sure that the initial content of our distance array is as high as possible. Okay. Because we are trying to minimize our distance array. After that, what we will do distance of 0 equal to 0 because in order to go from city number 0 to city number 0, the distance will be 0. That is 10. Now, as per the rules of priority, as per the rules of Dijkstra's algorithm, we will be declaring a priority queue. Why priority queue? Because this should be of min heap type. So this is the syntax for declaring a priority queue of min heap type. In that priority queue, we will push the source. Okay. So the total number of stops will be to 0 because the first is stop. Okay. So let me write here. It is equal to stop, number of stops, comma, node, comma, distance. So this is how I am putting it into the priority queue. Okay, so priority queue contains three values. The first value is stop. Then again, another pair which contains node and distance. Now this whole thing is again a pair. Okay, so this part is sure, I'm sure it's done. So it's pair. Pair. The first parameter is an integer, and the second parameter is again a pair. And with that pair contains two values: the source and the distance. Then finally, what we will do, we will run a while loop. Why? Because what we are trying to do, we will now process our priority queue. So we will take the first parameter as a stop. So the top element of the priority queue will sort itself accordingly. So whichever value has the least number of stops will come first. Okay, because stops become our judging parameter now. So that will be equal to pq.top.first. Okay, the first parameter. Now, since the second parameter of our priority queue was a pair, so what we will do, we'll do pq.top.second, which means the second parameter, then a dot first. So the first value of the second parameter will give me the node number, and the second value of the second parameter will give me the price, that is the cost. So now we have taken this node outside, and now we will process this node. And how we will process this node? We will just pop our node. Okay. After that, what we will do? We will run a for loop. Now this for loop will basically run across entire adjacency list. Okay, so auto adjacency node will be equal to adjacency. This is basically running across all the adjacent node of our given node under consideration. So we again take the three values as usual. We will take the child node, the node which we are considering. We will also take the edge as well. Okay, so this is the edge PR, and after that, what we will take? We will take the node stop. So node stop basically is that number of stops we have reached. So this will be equal to stop plus one. Okay. So the first value of adjacency contains the adjacency node dot first, and the second value contains the weight. Okay. So now what we will do? First condition we should check is that whether the number of node stop is less than or equal to k plus 1. Why less than or equal to k plus 1? Because we have to go at most k. Okay. So what we will do here is that when it is less than or equal to k plus 1, we will check now distance condition, whether we are able to reach the distance. Okay. Why we are getting node stop is equal to k plus 1? Because we can reach at most k. So let's say if node stop becomes k plus 1, it will, so it means that in order to reach the node, we are basically standing at it to k steps. Okay. And then we are trying to go to another node. Okay. So after that, what we will do? After that, we will check the distance. Okay, so distance of the child node if greater than the price plus the edge distance. Okay, so price to reach the current node plus the remaining distance if that is a less than the initial distance which we already have. In that case, we will update our distance array, and we will also push that into the priority queue. Okay, and you see the node stop is a new node that we are pushing because we have incremented the value of stop plus 1, and stop was nothing but the number of stops we have taken to reach that particular step. So initially stop will be 0 in the 0th node. After that stop will become 1 because we are reaching at a 1 node. Okay. And finally what is happening here is that see, the number of stops will only is not including the source and the destination. So if you are reaching a destination P, so it will take one more stop. So we are basically incremented for every stop we are going. So if you are reaching A, we are stop number 1, then we are reaching B, stop number 2, then we are reaching 3, stop number 3. But it may happen that 3 is our destination, but we are storing stop as number 3. But in fact, if we are going from 0 to 3, we had 2 stops. So destination is also getting counted. So that was the reason we took as k plus 1. So if node stop is less than equal to k plus 1, what we will do? The distance of child node is greater than price plus the edge. And then we will just push it into our priority queue. Okay, now this while loop will run. Now, as long as this while loop runs, as long as the priority queue is not empty, this while loop will run. After the while loop runs, we will check whether the destination that we are trying to reach it is 1 in 9 or not. If it is 1 in 9, it means that inside our Dijkstra's algorithm, we were never able to reach the distance. We were never be able to reach the destination because we could not optimize the distance. The distance is still 1 in 9. It means that it was impossible to reach their destination. So in that case, we will return -1. But if we were able to reach, we will just return distance. Okay. Why so? Because since I am making the number of nodes as a judging condition. So let us submit this code and see if there are any errors. So as you can see, there are no errors in this question, so therefore it is correct. So I hope we have almost done 2 questions. So next session also we will take up 2 questions. And meanwhile, since the next session should be on Sunday, which is a Christmas day, so since it's a holiday, we will not be having a next session on Sunday. We'll be having the next alternate day. Okay. So the next session will be on Tuesday, next coming Tuesday. Okay. So in the month of December, we will be having the graph series, and starting January, we will be having the tree series. Okay, tree series will be 2 times a week for the entire month of January. Okay, so to all the students who are new, so in the graph and tree session, we will be discussing all the important concepts related to graphs and trees, which are important from interview point of view. We'll also be discussing questions related to uh, interview questions only, mostly the famous interview questions. Okay, and apart from that, I would request everyone to kindly like this session, subscribe to our YouTube channel, and there is something called winter interview preparation is going on in Geeks for Geeks. So you can there is a link for that purpose. You can have a look at that. And tomorrow, 24 December, our CEO, Mr. Sandeep Jain, is coming live on a exclusive Zoom invite. In that case, what will happen is that you will get to you will get to interact with him personally, and it will be like an ask me anything session. So details are there in the description. Okay, and the slide link for today's session is also there. So kindly check that out. Okay, so I'm here for 2 minutes, and in case if you have any doubts, you can write in the chat box. Otherwise, we can wrap up the session. Any doubts in Okay, so let us wrap this session. So, a very good night to everyone and kindly enjoy your holidays as well. So, we'll meet up in the next session. Bye bye.